During an animal disease emergency, surveillance measures will be an essential component of the response activities. This just-in-time presentation will overview the importance and role of surveillance activities during an animal disease emergency situation, as well as the key factors and considerations during surveillance activities. Surveillance involves the ongoing systematic collection, analysis, and interpretation of health-related data. Information gathered will be essential for the planning, implementation, and evaluation of actions necessary for disease prevention and control. Surveillance measures needed during an animal disease emergency will be determined by the situation and the goal of the response. However, surveillance efforts will be ongoing throughout any response. Early in the response, surveillance efforts will be required to determine the extent of the outbreak, so appropriate control areas can be defined. Detection of infected animals or premises provides valuable data about the magnitude and distribution of the outbreak. This information will aid in developing the response actions and control measures needed for the situation. As the response progresses, surveillance information will help to monitor for any changes in the distribution of cases and aid in evaluating the effectiveness of the outbreak control strategies. Ultimately, surveillance data will help prove a location, whether it is a premise, state, or the nation, is free of the disease so that any trade limitations or restrictions that were made during the response can be lifted. This map shows the reported cases, indicated by stars, of cattle tick fever and quarantine zones, shown in yellow, established in Texas in 2009 to prevent the further spread of the disease and its vector. Before conducting any surveillance activity, it is important to know what your goal and your role will be. This will include knowing what information you will need to collect based on the goals of the response and the targeted disease. First, you must know what the suspected or confirmed disease you are dealing with is. This will be important for determining how easily the organism is spread and whether or not it affects humans. Answers to these questions will help determine the level of personal protective equipment and biosecurity measures needed during surveillance activities. What is the incubation period for the pathogen? This information will help when determining how far forward or backwards to go when gathering information during trace forwards or trace backs. How is the pathogen spread or transmitted? This will help to identify potential sources of the microorganism as well as potential means of spread to additional locations. You will also need to know what type of data you need to be collecting. Will you be conducting visual inspections of animals looking for signs of illness? Will you need to collect specific diagnostic samples? If so, what are the sampling requirements? Will you be conducting farm surveys to determine parameters such as vaccination status or environmental exposure to a particular disease vector or any recent importation history? If and when samples are collected, you will need to know what animals you need to collect from. This may include susceptible wildlife species. What is the sampling method? Will you be collecting blood samples or tissue samples or some other type of sample? What is the needed sample size for a particular premises? Or should samples be from individual animals, or are pooled samples needed? What will the sampling frequency be? Will it be daily, every other day, weekly? Much of this information will depend on the target pathogen and the population size, as well as the type of laboratory testing. The number of available personnel will also impact the level of and frequency of sampling that can be done. An essential component of any surveillance activity is the case definition. This information establishes a set of uniform criteria used to define what information or cases will be included or not included in the collection. A case definition is based on clinical, epidemiological, and/or laboratory parameters, such as clinical signs, morbidity or mortality rates, or diagnostic test results. It should also include the species to be tested, the specific geographic location, and the sampling time period based on the particular incubation period of the disease. Cases are classified depending on specific criteria, which represents increasing levels of certainty of the disease or pathogen's presence. Case classifications include negative, suspect, presumptive positive, and confirmed positive. A negative case will be an animal that does not show any clinical signs consistent with the disease and has no positive laboratory results. A suspect case is an animal that has clinical signs consistent with the disease, but at the time, no confirmed laboratory result. A presumptive positive case is an animal that has clinical signs consistent with the disease and case definition, in addition to a positive laboratory result and additional epidemiological indicators of infection. A confirmed positive case is an animal that has clinical signs consistent with the case definition and a positive isolation and identification of the particular pathogen. As an example, let's look at the sample case definition for highly pathogenic avian influenza, a highly contagious viral disease of poultry. Here, the definition of a suspect case includes any bird or animal with clinical signs consistent with highly pathogenic avian influenza. Note that clinical signs of a disease must be known and usually accompany a case definition. A presumptive positive case is one where the bird or animal has clinical signs, but there is also a positive laboratory result, commonly a screening type test, as well as epidemiological indication of the disease, for example, contact with infected animals. A confirmed positive case is one in which the diagnostic laboratory has completed the confirmatory testing, which is generally isolation and identification of the pathogen. Based on the classification of a particular case, the premises housing the tested animals will also be classified. Premises may be classified as infected, contact, suspect, at risk, or free. These designations are important as it will determine the response activities required to contain and further control the spread of the disease, such as quarantine or depopulation. It can also have trade implications, locally or internationally. Infected premises are those on which there is a presumptive positive or a confirmed positive case. The disease has been confirmed by a laboratory result. A contact premises is one where susceptible animals have been exposed directly or indirectly to animals, contaminated animal products, fomites, people, or aerosol from an infected premises. A suspect premises is the location where susceptible animals are under investigation for clinical signs compatible to the case definition. At-risk premises are those that are in close contact geographically with the infected premises but have no reported infections or clinically compatible signs of the disease. Premises outside the surveillance zone that have had no contact with an infected premises and have had no suspect cases under investigation are classified as free premises. Once a case and premises are classified, response actions will be necessary and initiated. This usually involves some level of quarantine measures, especially in cases of highly contagious or foreign animal disease. Zones are designated to define infected areas, which will typically be quarantined, or those areas in need of additional surveillance or assessment. This graphic shows a sample quarantine structure for an animal disease emergency. The infected premises is designated by the IP in the red box. Those farms or locations close to the infected premises are called contact premises, CP. Two are shown in the pink boxes. The area around the infected and suspected premises is called the infected zone. Outside this zone is an area where surveillance efforts may detect additional suspect, contact, or at-risk premises through tracing investigations. Farms with no indication of the disease have had no contact with an infected premises may be considered a free premises within the free zone. During a response, the infected zone and the buffer surveillance zone are jointly called the control zone. The boundaries of these zones may be modified as the outbreak progresses or draws to an end. Once suspected or positive cases are identified, efforts to trace additional cases must then be taken. The goal of tracing is to identify all possible contact premises in a timely manner after identifying infected premises. Epidemiological tracebacks involve finding and following the origins of animals brought onto the infected premises before the disease was noticed. These may be the source of infection. Their origin must be identified, together with any other locations that they may have infected during transit. Trace forwards involve the efforts to find and follow any animals that have left the infected premises during the critical period, which is defined by the disease of concern, when they may have been in contact with infected animals. These animals may be spreading the disease to new areas, so that the premises to which they have gone must be identified and investigated. Complete contact tracing will involve assessment of anything that could potentially spread the pathogen. This not only includes the infected or susceptible animals, but also any vehicles used to transport or that have had contact with the animals or premises. The movement of people on and off the farm must be accounted for, as should any transport or distribution of food or animal products. Surveillance efforts will require entry onto premises of unknown disease status. For this reason, biosecurity and safety measures are warranted to prevent the spread of pathogens or potential exposure in the case of zoonotic diseases. Personal protective equipment should include coveralls and boots that can either be disinfected or disposed of. If animals, tissues, or fluids will be handled, gloves must also be worn. If the disease of concern is zoonotic, enhanced PPE may include goggles and an appropriate respirator. All equipment used on the farm, including PPE, must be properly cleaned and disinfected prior to leaving the farm. Surveillance activities will involve interactions with the public, primarily producers, but also local veterinary practitioners and possibly the press. Good communication will be essential. Farm owners may react to teams requesting entry onto their property in many different ways, depending on the nature of the incidents. For example, a natural disaster situation versus a highly contagious disease outbreak, as well as the work to be performed. For example, examination and testing of animals versus a depopulation activity. When interacting with the owners, use the following guidelines. Always travel in teams. No one should be in the field alone. All field teams must have a cell phone and a phone number list. Upon arrival to the farm, approach the residents and knock on the door or ring the doorbell. Introduce yourself as a member of the response team and explain the reason for being at the premises. Avoid any confrontations. If the individual becomes threatening or confrontational, leave the premises immediately and contact your supervisor. Personal safety is always the first priority. For additional information on surveillance activities and methods, see the U.S. Department of Agriculture website. Information provided in this presentation was developed by the Center for Food Security and Public Health at Iowa State University's College of Veterinary Medicine through funding from the Multi-State Partnership for Security in Agriculture.